So in this video we will be make beam, I beam, circular beam and hollow beam. Then we will do analysis on the beam, on different types of beam and compare the results. Let's create a beam on SolidWorks, select front plane, sketch and make a circle of, let's say, 50 millimeter. Take okay, then do the extruded boss base, let's say by 500 millimeter. Okay, 500, press enter, press tick. Okay, do this, select and sketch on it, draw a circle on this and 50 millimeters and tick, then use it. Okay, click on the surface made and press on circle and make a circle of roughly 50. You can see it is aligned. Tick, go to features and 500. You can see as what the merge result is going to be. When we click on the merge result, this will be a single one beam. You can see as it is, there is no section. Okay, let's edit it. Okay, when we uncheck the merge results box, you will see two sections of beam. So why it is necessary to make a section? To do this analysis on it, to apply the forces on the points we create. So this is your beam. Okay, let's draw another one on it. Click, go to sketch, and this is the point where our circle is 50. It is 50. Feature, okay, extrude 500 result. Let's see and take again. Let's draw a circle. As you can see, here's the point. Radius 50. Click and extrude to check. Okay, uncheck the merge box. This. So this is your beam. So let me make it hollow. Okay, click on this and sketch. So let's make the radius of 40 mm. Tick and move to the feature extrude cut to cut inside. Okay, as you can see, it will be cut from only to 500 millimeters. Okay, let me show you. Okay, where is the beam? As you can see here, this is a section that is cut. So we can edit. This is the edit. This is edit, and we can do 1000. So that basically what I need to do was to cut these two sections of the beam and tick. These two are now cut, as you can see. Okay, let me hide it for a second. You can see. Okay, let me delete this and try again, as the feature is not done yet. So let's edit the circle. Okay, let's see. Diameter is 80, so radius is 40 as we did. Okay, now moving on to the feature extrude cut. So what I need is to cut two sections of the beam. So why I mean 1000. You can see this section will be also cut. Okay, let me check. This will this will basically change the side of the cut. As you can see, it will cut inward and this will cut outward. So let's check and see. Now as you can see, now our beam is cut into two sections. Both sides. Now you can see it's cut from both sections. So let's make it visible. This is your hollow beam. You can also cut through the whole beam. Okay, let's do some simulation in SolidWorks and click on simulation, SolidWorks simulation. As you can see, the simulation is here. Click on this. Let's wait for the part to get loaded. Now simulation is open. Click on new study and you can name your study whatever you want to give and press tick. So what we gonna do is first we will click on the part and apply material, whatever material you want to select. In our case, let's select aluminum alloy 1060. Okay, and parts. Now the material you should always do treat as beam. Every section to treat as beam. Okay, close this as 1060 aluminum alloy. Okay, treat all bodies as solid. And now create mesh. Now what we gonna do is treat as beam. Same over here, at every section treat as beam. So basically we were doing is a beam analysis, and you can see treating as beam we get a point 1, 2, 3 and 4. Okay, so basically next we have a fixed geometry at this point. As you can see, the arrows will show it is fixed. Okay, then we have our downward force, external loads, apply force. Okay, and click here. We have force on this, and this will show you at which plane the force will be acting upon. Okay, this face you can see the force. So I have a force in y direction, let's say 1000 Newton. So you can see the force on this point, let's say on this joint, and the face, this is selected. Now we need to see the on which face to force apply. Okay, you can see this. Okay, so let's do this for 0 and this 1000 and reverse the direction, downward force. Okay, and since the vertical force is 0, so no need. Okay, let's do it 1 to balance out forces. Okay, tick. So this is the simple analysis of the beam. Now we will be moving in mesh, create. What we will do is we will create mesh, and this type of structure will be shown. Okay, now this is mesh quality plot. Okay, Okay, and this apply mesh and run. As you will be showing, the beam is fixed from this end and the force is at this end, so the beam is like this. As you can see, the blue is the minimum yield strength and red is the maximum yield strength. So let's check out the displacement graph. So at the fixed end there is minimum displacement, and at the force end there is maximum displacement and force is acting upon it. So define factor of safety plot, tick, and this is your factor of safety plot. Okay, you can go into result and define whatever you need. So stress, so axial stress we need to check, and this is your result for axial stress. Moving on, define stress plot. Let's check for the torsional force. Since there is no moment applied, so there is no torsional force, I think so. Then moving on to result, and let's check the shear force. Click. This is your shear plot. The process is same. First you create the beam, check whether it's a circular beam, I-beam or hollow beam. In this case this is hollow, and you can do treat as beam and then points, then apply forces, take symmetry, and then mesh. Then you will create mesh and run and apply these different results what you want, and it will give it. So this analysis was in SolidWorks, and we can also do the same analysis on ANSYS workbench, but the analysis will be static structure. So I will be uploading this video, and there will be 2 to 3 more videos of beam analysis, on beam analysis.